Hi, how are you guys? I really hope you are good, and I really hope that, guys, the preparations towards your final exam are really working well. Please note that this is the sixth video, guys, from me answering the 2022 November Mathematics Paper 2, which was written by the learners who are enrolled under the Independent Examination Board. Um, this video, guys, will comprise of question 8, 11, and question 14 as well. I'll just cover trigonometry, like general trigonometry, in one video. Please stay tuned, guys, and please note that there are 5 videos which are already uploaded, and there will be 2 videos after this one. Just click the link on the description below to find the full memorandum. If there are things I'm not sure about, please do write on the comment section. I'll definitely come back and attend to you. If and if there are things you want me to clarify as well, please do write on the comment section. Don't forget to like the videos, guys. Any engagement is highly appreciated, and please don't forget to subscribe as well. Okay, question 8. The first question, I'm supposed to solve x and correct to one decimal place in the given interval. So since I'm given an interval, that means I'm supposed to find the actual x values. I must not just leave my answer as a general solution. Okay, let's just do that. We have 1 minus 2 sine squared x is equal to a negative 1 over 7. The first thing that you need to do, guys, if there are two things that you can change into one thing, just to make sure that you work with minimized terms, please, guys, do so. This is a double angle identity for cos, so I can simply write this thing as cos 2x is equal to a negative 1 over 7. Are we together? And therefore I have a trig ratio equals to a number. I can simply find my reference angle. So my reference angle, it's simply the inverse of cos 1 over 7. What do I get? Shift cos 1 over 7. This will give me 81.7. I'm supposed to round off to one decimal, ne? Okay, let's say it's 81.8 degrees. My duty is to express my reference angle where cos is negative. Why? Because cos 2x is equal to a negative number. I know that cos is negative both in the second and the fourth quadrant. So how can I express my reference angle? In my second quadrant, I'll express my reference angle as 2x is equals to 180 minus 81.8. Okay, let me write it. 180 minus the reference angle, which is 81.8, plus k 360, where k is an integer. This will give me 2x is equal to 180 minus 81.8. This will give me 98.2 plus k 360 degrees. Then I'll divide everything by 2. Whenever I divide everything by 2, I'll simply have x is equal to 98.2 divided by 2. This will give me 49.1 degrees plus k 180, where k is an integer. Okay, and then for the other solution, all I need to do is to express my reference angle in the other quadrant where cos is negative. I know cos is negative in the third quadrant. In the third quadrant, I represent my angles as 180 plus. So 2x is equal to 180 degrees plus 81.8 plus k 360, where k is an integer. Then 2x is equal to 180 plus 81.8. This will give me 261.8 degrees plus k 360. Then I can divide everything by 2. This will give me 130.9 degrees plus k 180, where k is an element of integers. Okay guys, by just doing this, I've just found my general solution. All I need to do is to find the actual x values within this interval. How can I do that? I must just keep on substituting the different values of k. That will give me any x value which is in that interval. For example, when x is 0, for the first solution, let me write the answers of the first solution in blue. Solutions. Okay, when k is 0, I know that x will be 49.1 degrees. Are you together? And then whenever I have 49.1 plus k 180. Okay, and then in space of k, whenever I substitute 1, I will get an answer which is greater than 90. So this thing simply means I don't have to go further and substitute 2 as an integer, because if 1 gives me a greater value, 2 will give me a higher value than the one that I get whenever I substitute 1. Then I must go to the negative values of k. Whenever I substitute -1 in space of k, I'll simply get x to be equal to negative 130.9 degrees. Whenever I substitute -2, let's see what I get. I get a value which is way less than 180, -180. So I don't have to go further. So these are the solutions for this part of the solution, for this part of the general solution. Okay, and then now let's go and focus on the other solution. Okay, I know that whenever I substitute 0 there in space of k, x will be equal to positive 130.9 degrees. And then whenever I substitute 1 in space of k, I will get a value which is greater than 90. So I don't have to worry about going further. But whenever I substitute -1, let's see what I get. -1, I'll get a negative 49.1 degrees. And I don't need to go further. Okay, let me check whenever I substitute to -2. -2 will give me a value which is way less than negative 180 degrees. So I don't need to go further and find the find the other x values. So these are the only solutions that we have here. These 4 solutions. Are you together? If you just did that, you would have aced your, how many marks? 5 marks. Okay. Second question, you're supposed to simplify the following to its simplest form. Basically, just leave it as one trig ratio or just a number. How can you do that? The most important thing, guys, whenever you deal with this type of questions, simplifying, basically, you need to make sure that you reduce your angles first. After reducing your angles, check whether there are 2 things you can change into 1 thing. If there are no things you can change into 1 thing, basically they're telling you like you must focus on the square identities or the double angle identities. For example, if you have something like this, sine squared x 1 minus sine squared x, if you come across something like this, you must change it into 1 thing. This will be equal to cos squared x. Are you together? If we have maybe if you had 2 cos squared x minus 1, you would have just changed this thing into 1 thing, which is what? Cos 2x. Are you together? So that's what the second rule says. The first rule, let's go to the first rule. Before, guys, we even start, I believe it's always wiser to build your structure whenever you reduce your angles. I have two terms here. And then I have a minus, then I have three terms. Okay, now I can just reduce my angles. This one is already reduced. I'll just leave it as negative cos of theta. And then whenever I see 90 plus, 90 minus, that means I'm supposed to change to the co-ratio. Are you together? So 90 plus is an angle which is found in the second quadrant. In the second quadrant, the trig ratio that I'm supposed to change to its co-ratio or cos. Cos is negative on the second quadrant. So before I change to the co-ratio of cos, I must assign the correct sign there. Yeah? So since cos is negative in the second quadrant, I'll just say negative sine cubed theta, like that. Okay, and then I have tan of 180 minus theta. 180 minus theta is in the second quadrant, and tan is negative there. So I'll just say negative tan theta, negative tan theta. Cos theta is already reduced, and then all the negative angles are in the fourth quadrant, and in the fourth quadrant cos is positive. So I'll just write cos cubed theta. Okay, now I've reduced my angles. Né? The only thing I'm left with is to make sure that I leave everything to be in terms of sine and cos. How can I do that? A negative cos times a negative sine cubed theta will give me positive cos theta multiplied by sine cubed theta. And then here a negative and a negative will give me a positive as well. So I'll say plus, I can write to tan as, let me use a different color, sine theta over cos theta, and this thing is multiplied by cos theta and cos cubed theta, like that. Now I have everything in terms of sine and cos. Are you together? I can cancel the ones that needs to be cancelled. This will cancel this one. I know that I'll be left with cos theta sine cubed theta plus sine theta cos cubed theta. I can take out a common factor here. I know that cos is common in both of these terms, so if I can take out to cos of theta as well as sine theta, because sine is also common in both of the terms, I'll be left with sine squared theta plus cos squared theta. I know that this will give me 1, so I'll be just left with cos theta sine theta. I can leave it like this, but if I wanna leave it, if I wanna have one trig ratio, I can just multiply this number by 1. Whenever you multiply a number by 1, there's nothing you are changing. How can I multiply this number by 1? I can simply say 1 over 2 multiplied by 2 sine theta cos theta. There's nothing that I've changed here because this can cancel with this thing. Are you together? So I've just multiplied the number by 1. There's nothing new that I've added. But I know that this will give me 1 over 2, and that thing inside the bracket will give me sine 2 theta. So this thing can be written as 1 over 2 sine 2 theta. You can leave your answer here, guys. There's nothing wrong, or you can choose to leave it here. That will be fine. Okay, now let's go to... We are done with question 8. Now let's go to question 11. Question 11. Okay, question 11. We are supposed to prove the identity We are given 1 plus sine 2x plus sine x minus cos x all over that thing is equal. We must show that the left hand side is equal to the right hand side. Ne? Whenever I prove identities, guys, you must always start with the most complicated side. Are you together? So on the left hand side, yes, I'm given the left hand side, ne? But I know that I have 1 minus cos squared theta plus, why am I using theta? But no, let me not rewrite what's already there. On the left hand side, guys, these two, 1 minus cos squared theta, they will give me sine squared theta. Ne? Remember that, guys, the rules of simplifying in trigonometry are the same. Whether you are simplifying, proving identities, finding the general solution, like you are going to use the same rules. Ne? Rule number 1, you must reduce all your angles. Rule number 2, check if there are two things that you can change into one thing. Rule number 3, change everything to be in terms of sine and cos, or rather, if you can change into one trig ratio, just do that, and then you'll just keep on repeating rule number 2 and 3, guys, until you finish. Are you together? So here the angles are already reduced. So all I need to do is to go and check my rule number 2. I have 1 minus cos squared theta squared x, right? This will give me sine squared x plus, yes, I do have sine 2x plus the sine squared x, which was given there. Please note that at the bottom I have 1 plus 2 sine x cos x plus, now I'm dealing with the double angle for cos. There are hints that guide you guys into which double angle you need to change to. If you have a positive 1 added to a positive cos 2x, that means you must choose a double angle for cos that will eliminate this one over here. Are you together? Remember that we have three of the double angles, right? We have cos 2x is equal to 2 cos squared x minus 1. Cos 2x is 1 minus 2 sine x squared, and then cos 2x is equal to cos squared x minus sine squared x. The only double angle identity for cos that can eliminate this one is this one that has a negative 1 over here. Are you together? Because you're trying to simplify, guys, big terms and make them to be as small as possible. Are you together? So whenever I see cos 2x, I'll just substitute 2 cos squared x minus 1, and then at the top these two will add one another. I'll have 2 sine squared x plus, and then now I'm supposed to change my double angle identity. This will give me 2 sine x cos x all over. The ones will just subtract one another. So at the bottom, no, let me just leave them. At the bottom, I'll simply have 2 sine x cos x plus 2 cos squared x. Are you together? And then I can take out a common factor both at the numerator and at the denominator. My common factor at the numerator is 2 sine x. Whenever I take out 2 sine x, I'll be left with sine x plus cos x. And then at the denominator, I can take out a common factor of 2 cos x. Whenever I do that, I will be left with sine x plus cos x. And then I know that these brackets will cancel with this one, and the 2's will also cancel one another. I will be left with sine x over cos x, right? And then I know that this will give me tan x. So now I've shown that the left hand side is equal to the right hand side. Okay. I'm supposed to determine the values of x for which the given identity will not be valid. The values of x, né? My identity, remember that, guys, the identity was 1 plus sine 2x minus plus sine squared x minus cos x all over 1 plus 2 sine x cos x 2 sine x cos x plus cos 2x. Okay, my identity, guys, will not be valid if and only if my denominator is equal to 0. If my denominator is equal to 0, therefore my identity will never be valid. Are you together? And whenever, guys, a number is not valid, this simply means the number is undefined. For a number to be undefined, 0 has to be at the denominator. Okay, so if I take my denominator equated to 0, I'll therefore find the x values that will make my identity to be invalid. Basically, I'm supposed to solve for x here. I have 1 plus 2x cos x plus, remember that whenever I have a 1 there, I'm supposed to change the double angle for cos with the 1 with the expansion that will eliminate the 1 there in front. So I'll simply choose 2 cos squared x minus 1 equal to 0. I know that the 1s will subtract one another. I'll simply have 2 sine x cos x plus 2 cos squared x is equal to 0. I can take out a common factor. A common factor is 2 cos x. I'll have sine x plus cos x is equal to 0. Now I have two things multiplied and the answer is 0. It simply means that the first one is 0. 2x is 0, or sine x plus cos x is the one which is equal to 0. Okay, let's deal with the first one. I can divide everything by 2 there. I'll be left with cos x being equal to 0. I know that my reference angle is just cos inverse of 0, and this will give me 90, but let me confirm. Yeah, this is 90 degrees. So all I need to do, guys, is to just express my reference angle where cos is positive, because 0 is not a negative number, right? Excuse me. I'll simply say x, cos is positive in the first quadrant, and in the first quadrant we just write our reference angle as it is. So x is equal to 90 degrees plus k 360, where k is an element of integers. Are we together? And then in the fourth quadrant, we write angles as 360 minus 90 will give me 270 plus k 360, where k is an integer. Are you together? So these are the general solutions of the x values that will give me 0 at the denominator rather. And then the other portion of it, I'll simply have sine x is equal to negative cos x. In this case, guys, I can divide both sides by cos x. Why? Because whenever I divide by cos x will never be eliminated in my equation. So I'll be simply left with tan x being equal to negative 1. Are you together? So my reference angle is just tan 1, which is 45 degrees. Are you together? So all I need to do is to express the 45 degrees in the second quadrant. Remember that, guys, for tan we only represent our angles either in the first quadrant or the second quadrant. If tan was equal to a positive number, I was going to express my angle in the first quadrant, but now since tan is equal to a negative number, I'm just going to express my angle in the second quadrant. So I'll simply say x is equal to 180 minus 45, that will give me 135, plus k 180 degrees, where k is an integer. Are you together? So these, guys, are the general solutions that will give me the x values that will make the identity to be undefined. That's how, guys, you're supposed to tackle that question. Now we are done with question 11. Let's go to question 14. Question 14. Okay, question 14, we are told that if sine 2a is plus sine, if cos 2a rather plus sine 2a is equal to that, where r is positive and b is an acute angle, determine the values of r and b. Okay. This is my conversion. Okay, how can we do that? We know that 2 cos 2a plus sine 2a is equal to r. You can expand the compound angle there. This will be equal to cos 2a cos r. Since we have a negative there, you'll write a plus sine 2a and the sine, why did I say sine r? Cos r rather, it's cos beta. Okay, so this will be equal to 2 cos 2a plus sine 2a. You'll get it in a minute now, guys. Why am I using different colors? There must be a plus in between there. I'm using different colors to indicate that this portion which is in the right hand side is equal to the other portion which is in the left hand side. How so? I know that since I have an r there outside, it will multiply both terms inside the bracket, right? So I'll have r cos 2a cos b plus r sine 2a sine beta. Okay. The first term in the left hand side is equal to the first term in the right hand side. The second term in the left hand side is equal to the second term in the right hand side. So this simply means that 2 cos 2a is equal to r cos 2a cos beta. And then I also know that sine 2a is equal to r sine 2a sine beta, like that. Okay, since, guys, I'm supposed to determine the values of r and the values of beta, that means a is just a constant term, and in maths, guys, I'm allowed to divide with constant terms. So whenever I do so, on this equation over here, I can divide both sides by cos 2a. I will be left with 2 being equal to r cos beta, and then this simply means that cos beta is equal to 2 over r all together. And then on the other side, since a is not what you are looking for, then you can take a as a constant term. We can divide both sides by your sine to a. Whenever we do that, I'll have 1 is equal to r sine beta. Therefore, sine of angle beta is 1 over r. So if, guys, we had a right angle triangle, our right angle triangle would have been like this. We would have beta here. Remember that sine is opposite over hypotenuse, right? So this would be 1 all over r, and then cos is adjacent over hypotenuse, that's 2 over r. Are you together? So in this rectangle, I have the opposite side and the adjacent side. I can therefore find the angle and also find the value of r over there. Ne? R is the hypotenuse. How can I find r? R squared is equal to 2 squared plus 1 squared. R squared is equal to 5. Therefore, r is the square root of 5. Are we together? And then how can I find beta? I know that the tan of angle beta is equal to opposite over adjacent. So the angle of beta, it's tan inverse 1 over 2. Tan inverse 1 over 2. Let me punch. Tan 1 over 2. This will give me 26.57 degrees as a value of beta. So I can therefore conclude, guys, that 2. Okay, let me use a different color. Which one? Let's go with red. I can therefore conclude that 2 cos 2a plus sine 2a is equal to the fifth root of cos 2a minus the angle of beta, which is 26.57 degrees. So this is how, guys, I was going to show that the value of r is root 5 and the value of beta is 26.57 degrees. That's how, guys, we're supposed to ace the first question in question 14. Free 6 marks over there. Okay, and then now we are being told that hence or otherwise determine the maximum value. In maths, guys, whenever they say hence, they're just hinting you that you must use what you found previously. Are you together? How can I do so? Remember that previously, guys, I had 2 cos 2a, but now I have 4 cos squared a. Ne? I must try to make this thing to look like this. How can I do so? 4 cos squared a. Remember that, guys. Whenever I'm trying to manipulate an expression, I must make sure that whatever I add, I must subtract, or whatever that I subtract, I must add to create balance. Are you together? So whenever I subtract 2, let me write in different color the manipulation I'm about to do. I'll have a plus 2 there as well. Whatever that I'm adding, guys, I'll also subtract. Ne? There's a sine to a as well. So I've just added 0 there. There's no change that I've made. Are you together? Because minus 2 plus 2 is equal to 0. So I've just added a 0. Okay, let's see how the manipulation may help us. If I can take out a common factor of 2, whenever I focus on the first 2 terms, I'll be left with 2 cos squared a minus 1. I'll still have a plus sine 2a plus 2 over there, ne? This would give me 2 cos 2a plus sine 2a plus a 2 there. But remember that 2 cos 2a is equal to something. All together, 2 cos 2a is equal to the square root of 5 multiplied by cos 2a minus beta. But remember that I already have a plus 2 there. So I must just add it. Okay, so now it will be easy for me, guys, to find the maximum value. Why is it going to be easy? Because I know for a fact that the graph of cos 2a minus beta, this graph will always be between -1 and 1. Are you together? But now I have a square root of 5. That means I must use this thing to create this type of expression there. How can I do that? There's a fifth root which is multiplied there. If I multiply this by square root of 5, I must also multiply by square root of 5 on both sides as well. Are you together? Remember that I have cos 2a minus beta. Okay, so if I multiply by the square root of 5 inside, that means I must multiply by the square root of 5 on the other two sides as well. Are you together? And then I'll end up having negative square root of 5 is between the square root of 5 cos 2a minus beta. Okay. But remember that there's a 2 there. If I add the 2 inside, I must add the 2 on the other two sides as well. So whenever I do that, I'll have a positive 2 minus the root 5 is in between root 5 cos of 2a minus beta plus a 2, and then I'll add a 2 this side as well. Okay, now I do have my expression, guys, because I know that's this thing over here. This is equal to 4 cos squared a plus sine 2a. So this is my minimum value and this is my maximum value. That's it, guys. So therefore I was asked to find the maximum. The maximum value is just 2 plus the square root of 5. I'm sorry that you had to do too much work, guys, just for 2 marks, but it's worth it. I really hope that, guys, the videos helped you out and you are gaining a lot. Please, guys, stay tuned and wait for more videos, and don't forget to subscribe, guys. Thank you.